A variable acceleration question here because the velocity is not just linear with t, it's dependent on t to the power of a half. So if we want to find the acceleration, which is going to be a vector because we're working in 2 dimensions, we're going to differentiate b. It's going to be the change in velocity with respect to time, dv by dt. Normally I write things as a column vector. I think in this case, it's just fine to leave it in ij form. So I'm going to get 3 over 2, t to the minus the half. When I differentiate t to the half, bring the half down, minus 1 from the power. Don't forget the I, which I always underline. I always underline my vectors to make it clear which ones are vectors and which ones are scalar quantities. And then it's going to be minus 2j. And that's our answer. We're leaving it in terms of t. To find the value of t at the instant when p is moving in the direction of I minus j. Okay, that is now relating to the velocity again. So I'm not going to have the velocity equal to I minus j. It's going to be some sort of scalar multiple. So I am now going to write it in column form. It's going to be 3 root t and then minus 2t. And that's going to equal k multiplied by 1 minus 1, some multiple of I minus j. I can now construct simultaneous equations. I've got 3 root t equaling k for the I component and minus 2t equaling minus k for the j component. Well, we can quickly get rid of the negative and write k equals 2t. And then I can bring the two together. It must be that 3 root t is equal to 2t. I think this is a really safe way to do it. Now t is greater than 0, so I'm going to actually divide through by root t here. I mean, there's different ways you could do it. I guess you could square both sides, but I think it's okay to just divide through by root t. So then 3 will equal 2 root t. And so if I come up here, root t will equal 3 over 2, and t will equal 9 over 4. You could write that as a decimal, 2.25 seconds if you wanted. I got to say, I don't always write the units in. It's kind of implied in the question we're using SI units, but you could if you wanted to. At time t seconds, where t is greater than 0, the position vector of p relative to fixed origin O is r meters. When t is equal to 1, r is equal to minus j. Find an expression for r in terms of t. So this is when we need to integrate because the derivative of r with respect to t is going to be the velocity. So r is going to be the integral of v with respect to t. I'm going to keep it in column form. So 3 t to the half, I'll write it back in index form, not 3 root t, and then minus 2t with respect to t. And that is going to give me, right now I increase the power by 1 and divide by the new power. So that's the same as times and by 2 over 3. I'm going to get a 2 here. And then minus 2t is going to become minus t squared. And then I'm going to add on c. Just going to write it as a vector c here, and then use this condition. So when t equals 1, r is equal to j. So that means I'm going to have 0 minus 1 equal to 2 times 1 to 3 over 2. That's just 2. And then minus 1 here, plus c. And therefore c, I can rearrange it, is going to be minus 2, 0. So r is then going to equal 2t to the 3 over 2 minus 2, and then minus t squared here. And finally, we're asked to find the exact distance of p from O at the distance when p is moving with speed 10 meters per second. So what I first of all need to do is, of course, get the time. And for that, I'm going to need to use this velocity that we had right at the beginning. And from it, get the speed in terms of t. So once I've got that, I can put t into r, work out the vector, how far we are away from the origin, and from that get the distance. So the speed is going to equal 3t to the half squared, using Pythagoras here, plus minus 2t squared square rooted, and that's equal to 10. So actually I can just square both sides and also expand the bracket. I'm going to get 9t plus 4t squared equal to 100. And that means 4t squared plus 9t minus 100 is equal to 0. This will actually factorize, although I just put it in my calculator. T is equal to 4 or minus 25 over 4, which I'm going to reject because it's negative. So brilliant, we've got ourselves the time. And then we're nearly there. So when t is equal to 4, the position vector, I've just got to put 4 into here. I'm going to get, well, 4 to the power of 3 over 2 is actually, I square root and I cube, I get 8, and I times by 2, 16, and minus 2, I get 14. Of course, use your calculator. Minus t squared is going to become minus 16. But remember, we're asked for the distance of P from O. So I've got myself a vector. Remember this, it's essentially this. I've got O and I've got this vector. I mean, okay, it's actually not drawn correctly because I'm going down, but it's still just to illustrate the point. So the distance is going to be 14 squared plus minus 16 squared, square rooted, which ends up being 2 root 113. Just put that into your calculator. We're there.